All right, we're beginning a unit on solving systems of equations and systems of inequalities, okay? And today we're going to focus on linear systems, and we're going to look at multiple approaches, but in this video, we're going to start with a graphical approach to solving the system, okay? I think graphically is a good way to start because you can conceptually understand what it is we're actually doing when we solve, all right? Okay, so in general, when we say to solve a system of equations, what we're trying to do is find the ordered pairs that satisfy all equations of the system. Okay, and it could be just a single ordered pair, it could be multiple ordered pairs to where you have more than one solution. Okay, now graphically, ordered pairs that satisfy all equations of the system would mean common points of intersections between the two graphs, okay? All right, so here I have a couple different systems, and we're just being asked if a particular point is in fact a solution to that system, okay? So when we say, is 1, 1 a solution to that system, we're meaning if we plug 1 in for x and 1 in for y into each of these equations, do we get true statements, okay? So let me start with the first equation, the top one, x minus 2y equals -1. If I make x 1 and I make y 1, let's see if I get a true statement. Absolutely do. 1 does in fact equal -1. And then if I do the same thing for the second equation, plug 1 in for x, 1 in for y, I end up with 3 plus 5 equals 8, or 8 equals 8. Since that is also true, I'm going to conclude yes, 1, 1 is a solution to the system. Okay, let's do the same thing with the next system here. Consider that an x value, consider that a y value. So is the point 2, -1 a solution? Let's plug into the top equation first. So y is -1, x is 2, -1 is equal to 4 minus 5, or -1 equals -1. So that is a solution to the first equation. What about the second equation of the system? 3 times an x value, 2, minus -1 equals 5. So that's 6 plus 1 equals 5, or 7 doesn't equal 5, right? So because the ordered pair only satisfied one of two equations in the system, we can't conclude it to be a solution to the overall system. So we're going to say no, 2, -1 is not a solution. Okay. All right, now let's talk about the different types of linear systems that you can end up with. Okay, there's 3 types of linear systems. Okay, the first is probably the most common, and it's titled or considered a consistent and independent system. This would be a linear system where the two lines only have one common point of intersection. Okay, one common point of intersection, therefore one solution to the equation or to the system. Okay, your next type of system would be a consistent and dependent type of system. This would actually be when you graph the two lines of the system, they would turn out to in fact be the same line. Okay, which means they have an infinite amount of intersection points, right? All of the points that are on each line are in fact common points. So we're going to say that this system has an infinite amount of solutions. Okay. All right, and then think about what's the other possibility. So two lines can intersect in one point, they can intersect in an infinite amount of points, or what's the third possibility? The two lines might not intersect at all. They would be parallel lines. When parallel lines are graphed, they have no intersection points, and therefore an inconsistent system has no solution. Okay, so those are your possibilities. All right, so let's move forward here. Example 2, let's solve the system of equations by graphing and then classify the system as either consistent and independent, consistent and dependent, or inconsistent. Okay, so you can see both of the equations of the system, they are linear and they're both in standard form. So I'm going to find the x and the y intercepts for each of these. Okay, so the top equation, x plus y equals 3, it has an x-intercept of 3, so that's the point 3, 0. And then it also has a y-intercept of 3, which is the point 0, 3. Okay, so here's that line. The second equation has an x-intercept of 3, and then it has a y-intercept of negative 6. So here's the second line, and you can see they are intersecting at one point, that x-intercept. So that is our solution. Okay, the solution to the system would be the ordered pair 3, 0. And since it's the only solution, that means we can classify this system as consistent and independent. Okay. All right, you have an example very similar to this that you can do for practice number 1 here. You're going to be given 2 equations. You want to graph them. Use the graph to determine the solution or solutions to the system and then what type of system it is. Pause the video, work through it yourself, and then come back, check your work with mine.